Hello everyone, in this video we're going to explore topic 9.6 solving motion problems using parametric and vector value functions. Alright, we're going to look at the definition, velocity and acceleration. If the function s of t and y of t are twice differentiable functions of t and r is a vector value function given by r of t equals s of t I plus y of t j, then the velocity vector and acceleration vector at time t are v of t is the first derivative of this one. So basically, you need to take the derivative of each component right here, right? Now acceleration, which is the second derivative of this one, right? And then you're gonna take the second derivative of each component, right? Now the speed is the magnitude of this guy, right? So basically, you're gonna take the square root of s prime t square plus y prime t square, right? Now let's take a look at the first example, velocity, acceleration, and speed. A particle moves along a plane curve described by r t equals 3 sine t over 2 I plus 3 cosine t over 2 j. Question A. Generate a rectangular equation that describes the particle's motion. Alright, so you know that this guy right here is the s component, right? And this guy right here is the y component, right? So I have s equals 3 sine t over 2, right? Then I'm gonna find sine t over 2 equals s over 3, right? Now I'm gonna square both sides. It's gonna be sine square t over 2 equals s square over 9, right? And y equals 3 cosine of t over 2. Then cosine of t over 2 equals y divided by 3. And then I'm going to square both sides, so it could be cosine square of t over 2 equals y square over 9, right? Now I'm going to add this guy up vertically, right? So what should I have? I have sine square of t over 2 plus cosine square of t over 2 equals s square over 9 plus y square over 9, right? But this guy right here equals 1, right? So I have s square over 9 plus y square over 9 equals 1. I'm going to multiply both sides by 9. So I have s square plus y square equals 9, right? Now we're going to review the circle equation. We have the standard form of the circle equation. It's going to be s minus h square plus y minus k square equals r square. Alright, so we look at this one right here. We know that h and k right here equals 0, right? Because we don't see anything right here. So the center is h and k, which is right at the origin, right? And the radius right here, you have r squared right here equals 9, and the radius is 3, right? Now, question B. Find the velocity vector, acceleration vector, and speed. So we're going to use the formula right here. Velocity vector is the first derivative of this one, right? So I have v of t is, take the derivative of this one. I'm going to use the formula sine u prime. It's going to be u prime times cosine u, right? So sine t over 2 can be written as sine of 1 over 2 times t, right? So when you take the derivative of this one, it's going to be 3 over 2 cosine of t over 2 I, right? Now the derivative of this one is going to be negative 3 over 2 sine of t over 2, right? J. Now, acceleration is the second derivative of this one or the first derivative of this guy right here, right? So I keep taking the derivative of v of t, right? So it's going to be negative 3 over 4 sine t over 2, right? Minus 3 over 4 cosine of t over 2 j right here, and this one is I, right? Now we need to calculate the speed, right? So the speed is magnitude of v of t, right? So it's going to be square root of this component right here, square. So it will be 3 over 2 cosine t over 2 square plus this component right here, square, right? It's going to be 3 over 2 sine of t over 2 all together square. So 3 over 2 square equals 9 over 4, right? This one is 9 over 4. I'm going to factor 9 over 4 out, right? So I have cosine square of t over 2 plus sine square of t over 2, right? Don't forget the square root sign. Now you know that this guy right here actually 1, right? So it could be square root of 9 over 4. And it turns out to be 3 over 2. Alright? Now let's move on to question C. Shows the particles path on the graph to the right. Be sure to show arrows to indicate direction. So we know that the particle moves along the circles right here, right? X squared plus y squared equals 9. The center is 0, the radius is 3, right? So center right here, radius is 3, so it could be right here, right here, right here, and right here. Now you just connect this point as a circle. Alright, next one, we need to show the arrows to indicate direction. So how do we know if the particles travel? Alright, clockwise or counterclockwise direction. Alright, so we need to create a table. Now, if t equals 0, you substitute 0 for t into the first one right here. Alright, you have sine 0 equals 0, right? So x equals 0. Substitute t equals 0 into this equation right here. Y equals 3, right? Because cosine 0 equals 1, right? So you have the first point is going to be right here, right? X equals 0, y equals 3, it's going to be right here. Right here, t equals 0. Right? Now we're going to plug in the second value so that t equals pi. The reason why I take pi is because if you substitute pi over here, right, it's going to give you the nice angle, right? So you have x equals 3 sine pi over 2, right? Sine pi over 2 equals 1, so x equals 3. Now y equals 3 cosine pi over 2. Cosine pi over 2 equals 0. So y equals 0, right? So x equals 3, y equals 0 is going to be right here. So at this point, t equals pi, right? And you know that the particle moves along this way, right? And it's going to be clockwise direction, right? Now question D. Find the velocity and acceleration at t equals pi. So t equals pi, we can use this guy right here, right? So we have v of pi equals 3 over 2 cosine pi over 2 I minus 3 over 2 sine pi over 2 j. Alright, I'm going to simplify. Cosine pi over 2 equals 0, right? So this guy is gone. Now sine pi over 2 equals 1, so this guy equals negative 3 over 2 j, right? Now a of pi. Substitute pi for t into this equation right here. Alright, so you have negative 3 over 4 sine pi over 2 I minus 3 over 4 cosine pi over 2 j, right? Sine pi over 2 equals 1, so the first one is negative 3 over 4 I, right? Cosine pi over 2 equals 0, so this guy turns out to be 0, right? Now we're gonna get the velocity and acceleration vectors right here. Now at t equals pi, so t equals pi should be right here, right? The I component is gone, right? Which means s is gone. The y component is negative 3 over 2, right? So you see that negative 3 over 2 is gonna go this way, and negative 3 over 2, which means negative 1.5, right? So it should be right here, right? Remember, it's going this way, it should be negative, going this way should be positive, going this way should be positive, and going this way should be negative, right? Now the second one, acceleration at t equals pi. You only have I component, which is you only have the s value, right? The y value equals 0, right? Negative 3 over 4 going this way, right? Because negative right here, right? So it's going to be negative 0.75, right? So it could be something like this. Right? So this one is v of pi. And this one is a of pi. Right? Now let's move on to example number 2. Motion along a curve. Sketch the path of an object moving along the plane curve given by rt equals t squared minus 3i plus dj. And find the velocity and acceleration vectors and speed at t equals 0 and t equals 2. Sketch the velocity and acceleration vectors on your curve below. Alright. Now, first, you need to sketch this one, right? So in order to sketch this one, you need to find the value of t, s, and y, right? Now, the s component is t squared minus 3, right? And the y component is t, right? So, you have the t just right here. T, S, and Y, right? We're gonna start with 0, right? At t equals 0, substitute over here. The s value is negative 3. The y value is 0, right? Now t equals 1. The s value is negative 2. The y value is 1, right? T equals 2. The s value is 1. The y value is 2. And t equals 3. The s value is 6. And the y value is 3, right? Now, if t equals negative 1, the s value is negative 2. The y value is negative 1. T equals negative 2. The s value is 1. The y value is negative 2. And t equals negative 3. The s value is 6. The y value is negative 3, right? Now we're gonna plot this order pair on the x and y coordinate right here. Now x was 6, y equals negative 3. So negative 3 and 6 it could be right here, right? X equals 1, y equals negative 2. X equals 1, y equals negative 2, it could be right here, right? X equals negative 2, y equals negative 1. So it could be right here. x equals negative 3, y equals 0, it could be right here. X equals negative 2, y equals 1, it could be right here. X equals 1, y equals 2, it could be right here. And x equals 6, y equals 3, it could be right here. Right? Now you connect this one is actually the horizontal parabola. Right? Now we need to find the velocity and acceleration vectors and speed at t equals 0 and t equals 2. Right? So before we're going to do that, we need to take the first and the second derivative of this one. Right? So I have v of t equals 2t I, right? Plus j, right? And then I have v of 0. It's going to be t equals 0, substitute over here. It's going to be j only, right? V of 2. Substitute 2 for t over here. It's going to be 4i plus j, right? Now, the acceleration a of t is the first derivative of this one, right? So it should be 2i, right? Plus derivative of this one is going to be 0j, right? So I don't need to write this one. Alright, so I have a of 0 is going to be 2i, right? And a of 2 is still 2i, right? Now, at t equals 0, the y component is 1, so t equals 0 is right here, right? So, the order pair should be negative 3 and 0 right here, right? So, it should be right here. Now, the y component is 1, and it's going up, right? Look, it's positive. So, 1 is going to be right here. So this one is V0, right? Now V of 2, so t equals 2 is going to be right here, right? So the order pair should be 1 and 2, right? X equals 1, y equals 2 is going to be right here, right? Now you have x component is 4. And y component is 1, right? So right at this one, x component is 4, it's going to the right? Because it's positive. So you count 4 to the right. And this is 1 up, right? So it will be right here. So you just get this one. Alright, so this one is v of 2. Now, a of t is equal to I, right? I of 0 equals 2i, right? So 0 is right here. T equals 0, right? It's going to be 2i. So you don't have the y component. You only have s component. And 2 is positive, so it's going this way, right? So it could be right here. Alright, so this one is a of 0. Now, a of 2. So t equals 2. Right? So at this point, 1 and 2. So it's going to be right here. Right? So you have s component is 2. So it's positive, right? So it's going this way. So this one is a of 2. Now let's move on to example number 3. Motion along a curve. Number 2. Sketch the path of an object moving along the plane curve, given by r of t equals e to the t I plus natural log of t j. Alright, so this one actually the s and this one actually the y, right? Now we're gonna sketch the t-charge. Remember that the domain of this one is t greater than 0, right? Because you know that the domain of the log function is going to be a greater than 0, a not equal to 1. and b should be greater than 0, right? Now, natural log of t can be written as log base e of t, right? So b in this situation is t right here, right? So t must be greater than 0, right? So I have t right here, s right here, and y, right? So t equals 1, and then s equals e, right? And then y equals 0, right? Because natural log of 1 equals 0. Now t equals 2, s equals e squared, right? Y equals natural log of 2, right? And t equals 3, it could be e to the third, and this one natural log of 3, right? When t approaches 0, then e to the t approaches 1, right? So have the vertical asymptote is right here. Now, at t equals 1, x equals e, y equals 0, right? So, it's going to be somewhere right here. You know that e is the Euler number. It's going to be 2.718, etc. Right? So this guy right here. At t equals 1, s equals e, y equals 0. Right? At t equals 2, s equals e squared. Right? Now you need to convert this one to decimal. Right? So you just press Control and then Enter right here. It's going to be 7.38. Right? It's going to be right here. And y equals natural log of 2, so you just press natural log Control, natural log right here of 2, press Enter. Convert this one to decimal, press Control, Enter. It could be 0.693, right? So it could be somewhere right here. Alright, now t for 3, s for e cubed, right? So you're gonna press e cubed, enter, convert this one to decimal. It should be 20 point something, so this is 22, this is 20 point something, it should be somewhere right here. Y equals natural log of 3, so if you press natural log of 3, press enter, convert this one to decimal. It's gonna be 1 point something, right? So it's gonna be right here, right here. Alright, so if you grab it, it could be something like this. Now we can use the calculator to check our work. Alright, so you just go to the home screen, press graph right here. You need to turn the graph into the parametric mode, right? Because this one is the parametric equations, right? So you're gonna press menu number 3, number 4. Alright, it's gonna be right here. Now you need to enter the function, right? S equals e to the t, right? So it could be e to the t. Y right here should be natural log of t, right? I remember t should be greater than 0, right? So I'm gonna press Control and equal sign right here, right? It should be this guy. And then I just extend this number to number 10. Alright, so I press enter. It's gonna be something like this. Alright, now if you want to know the orientation of this part of the object, you're gonna press menu number 5 trace, number 4 path plot, and number 2 parametric. Alright, and you just press the start animation right here and enjoy. Alright, so you know that the particle moving along this direction. Alright, now question B. Find the velocity and acceleration vectors at t equals 1. the speed is for question D right here, right? Now velocity, we're gonna take derivative of this one right here, right? So we have v of t is e to the t I, right? Plus 1 over t j, right? Now you have v of 1. It's going to be e to the 1 is going to be e I, right? Plus 1 over 1 is going to be 1j, so I just write j, right? Now a of t is, take derivative of v of t, it's going to be e to the t I plus derivative of 1 over t is going to be negative 1 over t squared, right? J, right? Then you have a of 1. It's going to be e I minus j, right? Now question C. Sketch the velocity and acceleration vectors on your curve above and to the right. It's going to be right here. So at t equals 1. Now v of 1 equals e I plus j, right? So at t equals 1, s equals e, and y equals 1, right? Now t for 1, s for e is right here, right? Y equals 1, so it could be right here. Alright, so let's go to the right e unit and go up 1 unit, right? So 1 is right here. So the end point should be right here. And this one is v of 1, right? Alright, now similarly, we need to sketch a of 1, right? So at t equals 1, s equals e, and y equals negative 1, right? So it's exactly the same thing. Y for negative 1 is going down right here, so negative 1 right here. So it should be somewhere right here. So this one is a of 1. Now let's move on to question D. Find the speed at t equals 1. Alright, so you know that the velocity function is right here. Alright, so the speed should be magnitude of this component, right? So it can be square root of e to the t square plus 1 over t square, right? And then you need to evaluate this one at t equals 1, right? It's like t equals 1. So it's going to be square root of e square plus 1, right? You just leave the answer like this. You don't need to convert this one to decimal, right? Now, question E. What happens to the position, velocity, and acceleration as t approaches infinity? Now, you look at the position function r of t right here, right? So have r of t equals e to the t I plus natural log of t j, right? So when t approaches infinity, right? S equals e to the t approaches infinity, y equals natural log of t approaches infinity, right? Or you can look at the graph right here, right? When t approaches infinity, s approaches infinity, y right here approaches infinity. You see that it keeps going further to the right and upward, right? So we have this one, right? Now the velocity, so the velocity function is right here, right? So we copy this one down over here. Now when t approaches infinity, the s component is e to the t approaches infinity, right? The y component is 1 over t approaches 0, right? Now the last one, acceleration, is going to be right here, right? So a of t is e to the t I minus 1 over t squared j, right? When t approaches infinity, s equals e to the t, which is this guy right here, approaches infinity, and y equals negative 1 over t squared right here, approaches 0, right? Now let's move on to statement number 4. A particle starts at rest, which means v of 0 equals 0i plus 0j, right? T equals 0, and then v equals 0. From the point negative 1 and 2, this one is the component I and j of the position, with an acceleration vector of a of t equals I plus 2j. Find the location of the particle at t equals 2. Alright, so given the position function, if you check the first derivative of this one is actually the velocity function, right? If you check the first derivative of the velocity function, it's going to be the acceleration, right? Now, you given the acceleration function, you need to do backwards, right? So you need to take anti-derivative of this guy right here to get the velocity function. Velocity function is the anti-derivative of the acceleration, right? So it's going to be anti-derivative of I plus 2j dt, right? And anti-derivative of I here, coefficient is 1, right? So it could be t. Don't forget to add the constant c1, I, right? Anti-derivative of 2 is going to be 2t, right? So plus 2t. Don't forget to add the constant c2, j, right? Now we need to solve for c1 and c2. So we're going to use the given information right here. Alright, so v of 0 equals 0i plus 0j, right? So I have v of 0, substitute 0 for t into this guy right here. So then I have 0 plus c1 I plus 2 times 0 plus c2 j, right? Then this guy actually equals this one right here, right? 0i plus 0j, right? Now I just equate the component, right? This guy and this guy must be the same. So I have a system of two equations. 0 plus c1 equals 0, right? The second one is right here, right? I have 2 times 0 plus c2 equals 0, right? So to solve system of equation, I have c1 equals 0, c2 equals 0, right? Then I have v of t is ti plus 2tj, right? Now I'm gonna find the position function by taking anti-derivative of the velocity function, right? So s of t equals anti-derivative of v of t dt, right? So it's gonna be anti-derivative of ti plus 2tj dt, right? So it's going to be t squared over 2. Don't forget to add c3, right? I plus t squared plus c4j, right? Now we're going to use the order pair right here, right? At t equals 0, the position is negative 1, and 2, right? So I have S of 0 equals, substitute 0 for t, right? It's going to be C3I, right? Plus C4J. This one equals negative 1I plus 2J, right? So I just equate the component, right? This guy and this guy must be the same. So I have a system of equation C3 equals negative 1, right? This guy and this guy must be the same. C4 equals 2, right? So the precision function is S of t is right here, right? It's gonna be 1/2 t squared minus 1 I t squared plus 2j, right? Now, you need to answer the question, find the location of the particle at t equals 2. So, you have S of 2 equals t equal to, substitute 2 for t, so 2 squared equals 4 divided by 2, it could be 2, minus 1 is going to be 1, so it should be I, right? Plus 2 squared equals 4 plus 2 equals 6, so 6j, right? So this guy is the same thing as at t equals 2. The particle is S. The point 1, 6. Let's move on to example number 5. A particle with an initial velocity I plus j and the initial position 1, 1 has acceleration vector I of t equals negative cosine t I plus sine t j. Find the location of the particle at t equals pi. Now again, example number 5 similar to example number 4. You need to take anti-derivative of the function I of t to get the function v of t, right? So it can be anti-derivative of negative cosine t I plus sine t j dt, right? So anti-derivative of cosine is going to be sine, right? So it will be negative sine t. Don't forget to add the constant C1, right? This one is the I component, right? Plus anti-derivative of sine should be negative cosine, right? So negative cosine t plus C2j, right? Now we're going to use the fact that initial velocities I and j. What does it mean? It means v of 0 equals I plus j, right? So we have v of 0, substitute 0 for t into this one, right? So I have sine of 0 equals 0, I only have c1 left, right? c1 I. Now cosine of 0 equals 1, so you have negative 1 right here, so negative 1 plus C2j, right? And this one right here actually I plus j right here, right? Now you just equate the components, right? C1 must be equal to 1, right? So I have a system of two equations, C1 equals 1 and negative 1 plus C2 equals this one right here, 1. I solve a system of two equations, right? So C1 equals 1 and C2 equals 2, right? So my v of t equals negative sine t plus 1 I plus negative cosine t plus 2j, right? Now, to find the position function, annotate antiderivative of the velocity functions, right? So, S of t is antiderivative of negative sine t plus 1 I plus negative cosine t plus 2j dt, right? Now, antiderivative of sine is going to be negative cosine, and you have negative sine, it becomes positive, right? So positive cosine t. Antiderivative of 1 should be t, right? So plus t. And then don't forget to add C3. This one is the I component, right? Antiderivative of cosine t is going to be sine t, right? So it's going to be negative sine t plus 2t, right? Plus c for j, right? At t equals 0, initial position is right here, right? So this guy equals I plus j, right? So I have s of 0, substitute 0 for t into this guy right here. So I have cosine 0 equals 1, right? So I have 1 plus 0, right? Plus c3 I. Now the second one, sine 0 equals 0. 2 times 0 equals 0. I only have c4 left. Plus c4 j, right? And this one equals 1i plus 1j, right? Now I just equate the components, right? So this guy equals this guy. So I have a system of two equations. 1 plus c3 equals 1, and c4 equals 1, right? So c3 equals 0 and c4 equals 1, right? Now my answer for the position function is s of t is cosine t plus t plus c3 is going to be 0, right? So I only have this one is the I component, right? Now plus negative sine t plus 2t c4 equals 1 plus 1. This one is the j components, right? Now we need to find the location of the particle at t equals pi. So you have s of pi is cosine pi equals negative 1, right? So you have negative 1 plus pi. This one is the I component. Now sine pi equals 0, right? So I only have plus 2 pi plus 1 left, right? So this one is the j component, right? Now you can conclude that at time t equals pi, the particle is at negative 1 plus pi and 2 pi plus 1, right? Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.